Which of the following bases can remove the proton from a terminal alkyne in a reaction that favors the products? A terminal alkyne is an alkyne at the end of a chain. And what we are talking about here, if we're using a base and removing a proton, we are looking at an acid-base equilibrium. So we want to see a reaction where we have a base that is a strong enough base to remove that terminal alkyne hydrogen to give the acetylide ion and the conjugate acid of the base. So in order for this reaction to favor the products, that means that on the product side, you need to have the weaker acid and the weaker base. Terminal alkynes have a pKa value of approximately 25. So that means we want bases whose conjugate acids have pKa's greater than 25. So if we look at our bases here, one is hydroxide. The conjugate acid of hydroxide is water, which has a pKa value of 15.7. So that would not work. Would need to be greater than 25. If we look at our second option, the amide, the conjugate acid of that is ammonia, which has a pKa of around 38. So this base would be strong enough. The third option is an anion of an alkane. So if we put a hydrogen back onto that last carbon atom to draw the conjugate acid, we would see an alkane. Alkanes are very weak acids with pKa's of approximately 60. So this base would also be strong enough, which means that 2 and 3 would be the only ones strong enough to do this reaction.